it says, let's go to the numerical approach. This means constructing a table of values. Evaluate the function, and I have a function, and notice that there's no drawing. Now we just got to figure this out, right? At several x values near 0 and use the results to estimate the limit as x approaches 0 of that function. So notice what is happening to this table. I am getting closer and closer to 0. Look, it starts at negative 0.2, negative 0.1, negative 0.01, negative 0.001. I'm getting closer and closer to 0. Do you guys see that? This one is approaching from the left. So here's how I type this in. I take my calculator. So I have a TI-84 at the moment. I don't know if you guys can see that. I'll have a big one, but I'll have a bigger calculator hopefully by the end of the week. And I'm going to push the y equals button. And how do I get a fraction in there? So all the 84s should look like this. I get a fraction by pushing the alpha and then the y equals button. ND, like that. See? And I'm just going to type in x divided by, okay. The y equals is top left-hand corner. So push that. Yeah. Well, you got to push y equals first.
Yeah, I press y equals and then I press alpha y equals.
And now push enter. And then if you push alpha y equals, you get the whole numerator denominator thing. So there's my little fraction. And I'm going to type in square root in the bottom. X plus 1. Where is the x? The x is right next to the alpha key. And then I'm going to get out of there. And I'm going to put minus 1. The square root is second and the x squared on the left hand side. What did I what? X. So right next to the alpha key, just push that. It says x, t, theta, and n. Push that button. And then square root of x plus 1, and then minus 1. Is everyone okay so far? All right. Now, before I click on table, I need to set my table to, because I want to be able to type those numbers in. So you see where it says table set in blue? It might be a different color in yours. So mine is second and then the window button. And I get this screen. I'll do it again. So I'm right here. I push the second button and then the window button, which is says table set. And don't worry, guys. We're just learning how to use calculators. It's worse. It's worse with the Inspire. It wasn't hard, no. I would just use Desmos all the time. And then towards the end, we started using calculators. So here we go. On the independent, which is the x value, put ask. So now the ask should be highlighted. Push enter, yeah. And now I'm going to push second graph, which really is second table. So the graph button is the far right, upper right hand corner. And now your x and y should be blank like that. So I'm going to type in negative 0.2. So negative 0.2, push enter, and I get a number. Do you guys get 1.8944? You're going to have to teach me, Parker, how to do it on the Inspire really fast. And see if you can get fast with it. All right, guys. So I got a number, 1.8944. Did everyone get that same number? So write it in, 1.8944. Now we're going to type in negative 0.1. We're going to get closer and closer to it. So here we go. Negative 0.1. Oh, there's nothing in there. Negative 0.1. And I got 1.9487. Now I'm going to type negative 0.01. Negative 0.01. 1.995. And then negative 0.001. Negative 0.001. 1.9995. Okay, now that we filled out this table, let's look at it. Does it look like f of x is approaching a specific value? Yeah, it looks like it's approaching. I know x is approaching 0, but what does it look like f of x is approaching? It looks like it's approaching 2. It looks like it. We'll see in a little bit. Let's approach from the right-hand side. Now do the same thing, but put positives instead of negatives. So I'm going to go and we'll point 2, 2.0954, 2.0954, 0.1, 2.0488, 0.01, 2.005, and 0.001. 2.0005. All right, now let's look at this one. It's the second table. As x approaches 0 from the right, does it look like I'm approaching the value 2? Yeah, it does. Look, 2.09, 2.04, 2.005, 2.0005. It is definitely getting closer and closer to 2, guys. Show this. Let's see what we found the concept. And then we'll see if we can figure it out. All right, how do we feel, guys? So here we go. Is everyone able to use your calculator to get these values? All right, so by the way, on the AP exam, you don't have Desmos. Last year we did it with Desmos, and then we could see what it was. This is what you have, so that's why I'm telling you, the calculator that you want to get good at, that's the one that you should use all the time. If you want to get good with the Inspire, use that. If you want to get good with the 84, use that. For speed, I like the 84. I don't know the Inspire inside and out, but I can figure it out, and we can see what's up. All right. So from this, we can conclude the limit of x approaches 0 of x over the square root of x plus 1 minus 1 is equal to 2. And that's it. We're going to do the same thing with sine x over x. So I'm going to go to y equals. So look, we're doing it again, and I'm sorry that my calculator is really small here. Can I make it bigger? No.
Can you clear it or?
Yeah, you can.
Sorry.
I just push clear, and there it is. It just deletes it.
Just change the equation or
No, the table's still in there. You can just push the clear button or delete. The delete takes everything out. We didn't graph. What?
She was like, so let's get to a graph. She found a graph.
Yeah, because you don't have to graph. All right, here we go, guys. I'm going to push sine x over x. I'm going to push alpha y equals to get the little fraction. I'll put sine x on the top. And I'm going to put x on the bottom. And now that I already have my table set, I can just go right to the table. And I can just type in 0.2. And let me tell you what I get for 0.2. I get 0.99335. Is that what you guys get? No? Check your mode that you're in radian mode. Yeah, I'm in radian. Alpha y equals. And then push enter. The very first one. Yeah, you can just type in sine right below the apps button, and then x divided by x. I got 0.99335. Put that in there, guys. It fixes the table. 0.1. Yeah, so I should have probably left it. 0.99833. Second table. Second graph. Oops, I did the one on the bottom instead. 0.01. .999912348. 0.001. It says 1. Hold on, real quick, guys. I just need your attention really fast. Be careful. It says 1. When you put .001, the y value says 1. But if you hover over the 1, look what it is. It's actually .99999999998. Nine 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 nine.
I put in the equation, I think correctly, but then it gave me all of the same values in the table, and so I don't think I did that right. Your explanations still apply.
Yes, because it's the same operating system. The only difference is that one's more modern. Are we still okay, guys?
Yes.
All right. I'm assuming, I shouldn't assume. This is an even function, so I'm assuming these values in the top are going to be the same, but you guys tell me. I may be wrong. I'm wrong pretty often. So when it says something like this, we should be sus. Like scroll to the right. Push right. How do we feel, guys? Okay, now check it out. Does it look like this limit is approaching something? Yeah, it's approaching what? So the limit as x approaches 0, sine x over x is 1. If it's something specific like this, where I'm telling you to fill in a table for this accuracy, you would have a calculator. Yes. Not if it doesn't approach something, then it's like let's say the top one approached 1 and the bottom one did not converge to anything, then we would say it does not exist. You know what I mean? How do we feel? Which you're gonna get some practice on that on Delta. Delta has a calculator and then they make you type in stuff. Okay. All right, guys, and then I put some information on this. Do you guys want to read that to yourselves really quick? So it just pretty much tells you if you were to graph it, it looks like it's 1. So look, here's my graph. And my graph sucks right now because I'm so zoomed out. Let me zoom in. So here I am zooming in. Now initially, and I know I apologize that this graph is so small. Hopefully by the end of the week, TI will send me a brand new calculator that takes up the whole screen. Initially, it looks like it's continuous. It is not continuous at 0, guys. It's just that this is not a high definition screen. Or maybe the pixel's taken up by the y-axis. It is not continuous at 0. If I were to go to the table, and you don't have to do this, just listen. If I were to put the number 0 in here, I'm going to get an error on the right-hand side. Look at this. 0. 0. Oh, just 1 0. Enter. Look, it says error. Because you can't divide by 0. Does that make sense, guys? So that graph actually has a hole right on the y-axis. So this does not have a y-intercept. It looks like it does, but it does not. Cool? Any questions right now? I was looking at what happens when I type in the number 0. Then I get the word error. That's because I don't have a y-intercept. But on the graph, it looks like I do. It looks like it crosses the y-axis at 1. If you're undefined, or if you have factors in the top that cancel, if it's a polynomial, if the factors cancel out, and then we're going to get into that today, actually. All right. What do you have to memorize? Really, there's only one, and you don't even really have to memorize it. This one right here is the special limit. It is also the same as limit as x approaches 0. of x over sine x. That is also 1. And let me write it a different way real quick. Limit as happy face approaches 0 of sine of happy face over happy face. This will always be what? 1. If you're a happy face hater, I can use symbols. Do you want me to use a triangle instead? What's up?
So is it the same either if sine x or x over
Yeah, because the reciprocal of 1 is 1. I think that's probably the best way. That even if you flip it, it's still going to be... Are we okay, guys? Okay. So check it out. If you read... obviously, I took this from some book. If you're wondering what book, it's the Denominator book. It says theorem 2. We don't have to memorize what theorem, blah, blah, blah. Tell me, guys, read this really quick to yourselves. Do you understand what it says? I'll tell you what it says in a little bit in plain English. You know what they tried to say on that? Does anyone understand what they tried to say? It's trying to tell you, try, direct, substitution. As long as denominator is not 0. That's what it's saying. So this means polynomial in the top. So then they're saying that if I have a polynomial that I can just do direct substitution, and you can just do direct substitution for all your x variables. That's where your c comes in. And then finally it says if I have a function that's a polynomial in the top, polynomial in the bottom, direct, as long as denominator is not 0. That's what they're trying to say with all that paragraph, but they don't. I think when they wrote it, they thought that like, oh, everyone's a, But that's what it's trying. That's what it was trying to say. So that's why sometimes students get intimidated by math because they see something like this and like, I have no idea what they're trying to say. They're trying to say try direct substitution first. Cool or not cool? Okay, so I'm looking at example 3. I have a polynomial because if you distribute it, you got a polynomial there. Can I? Or actually, it's even better. I don't even have a rational function. Can I do direct substitution? Yeah, try it first. Direct substitution. I no longer write the word limit because I'm just writing the number. 3 squared, 2 minus 3. You can actually leave it like that, but don't. Let's simplify it. What's 3 squared? 9. 2 minus 3 is? So this limit is negative 9. Then that's it. Look at letter B. Letter B, as long as I don't get a 0 in the denominator, can I do direct substitution? Yes. Let's do direct substitution. 2 squared plus 2 times 2 plus 4 over 2 plus 2. And let's see what we get. 2 squared is 4. 2 times 2 is 4. And then plus another 4. All divided by 4. 3. If you were to graph this function, when x is 2, the y value would be 3. It'd be a nice continuous function. Because nothing cancels out, nothing, like it'd be a nice, pretty graph. No holes, no nothing.
So, Mr. Chavez?
Yes, ma'am.
Hey, we are ready for any students that want to participate in COVID testing. Read on your QR code. Please go ahead and head.
Okay. Test. Yeah, we're back. All right, guys, so here we go. On this question here, we have tan x over x. First, we see if we can do direct substitution. Can we do direct substitution? Why not? Yeah, you get 0 on the bottom. So now you're going to have to rely on your pre-cal. The only rule we know right now, put a side note somewhere, we know this. Limit as x approaches 0 of sine x over x is equal to? That's the only rule we know. So what we want to do, we want to get somehow to get this to look like sine x over x. So limit as x approaches 0. And tan is the same thing as what over what? Perfect. Sine x over x cosine x. This in blue that I'm circling is your tan x. Do you guys see that? Okay. So now I'm going to expand it. I can write the word limit. I haven't evaluated it yet. So if you haven't evaluated, keep with the word limit. X approaches 0, and I'm going to write a giant parenthesis. And I'm going to do this. I'm going to write sine x over x times 1 over cosine x. Have I confused anyone? Is this what I have in parentheses the same thing as sine x over x cosine x? Perfect. I already know what the limit of sine x over x as x approaches 0 is. What is that? That's a 1. So I have 1 times, now for the cosine x, here's where your pre-calc comes in. Oh, we didn't do the pre-calc quiz. Oh well, tomorrow. For the cosine x, can I do direct substitution for that one? Yeah, what is cosine of 0? 1. So 1 divided by 1, that's a 1. So this tan x over x, that limit is just 1. So this limit is just, and I guess you can add it to your collection. So collection, let's see, limit as x approaches 0 of tan x over x is just 1. That is also true. Limit as x approaches 0 of x over tan x is also 1. If you want to replace the x with a happy face, you can. Any questions so far? What's up?
On the question, 1 over cosine x, isn't x? Wait, how did you get 1 from that?
I substituted 0. Cosine of 0 is a 1. So I'll write it here.
So you can substitute the 0 throughout the equation, just not.
Yeah, not in this one because you get divided by 0. But if you expand it like so, this one we didn't substitute it on this one, but we did the property, see? And on this one here, we just did direct substitution, and the cosine of 0 is 1. Do you see what we did? Did that make sense, guys? Okay. The table over there, you guys good? Okay. I sometimes worry because you guys are way back there, and it's so easy to get distracted. Arispe, you guys solid on this one? You guys okay? For sure? Come on, guys. We have a goal here, remember. All right, here we go. Go to the next one. Now we're going to see how good your algebra is. Can I do direct substitution for number 5? Not immediately, no. Because if you do direct substitution, you get a what in the bottom. So you got to figure something else out. So you got to observe. Yes, you can probably graph it maybe. You got to observe the top is the difference of squares. Do you remember what the difference of squares looks like when you factor it out? Yeah, a plus b, a minus b. So write that down somewhere. That's called the difference of squares. So here we go. I'm going to write the word limit because you haven't evaluated it yet, guys. So that's the most common mistake that you guys forget the word limit. As x approaches 1, and the top is the difference of squares, I'm going to write x plus 1, x minus 1, over x minus 1. Or if you want to do the algebra on the side, you can. Now, what can I delete? The x minus 1's cancel out. Now can I do direct substitution? Yes. Once you do direct substitution, you no longer need to write the word limit. What is 1 plus 1? There it is. Do you see how we did it, guys? Okay, we're going to keep going. Let's see. Letter A. Can I do direct substitution? No, it's pretty much the same as the one we just did, so I probably wasn't paying attention when I was typing. So here we go. Limit as x approaches 1. The top stays as x minus 1. The bottom is the difference of squares. X plus 1, x minus 1. The x minus 1's cancel out. I can do direct substitution, and I have 1 over 2. Does everyone see how I got a half?
So you leave the 1 on the top, right?
Oh yeah, because there's nothing on the top, so it's like a 1. Are we okay, guys? Look at letter B. Can I do direct substitution? No, because if I do direct substitution, you get 0 over 0. By the way, if you get 0 over 0, more than likely it has a limit. There's also a rule called L'Hopital's rule if you get an indeterminate form, but we're not there yet, so we're not going to talk about that. What can I factor out in the numerator? An x squared. Perfect. Factor out the x squared, you're going to get 3x plus 20. In the denominator, what else can I factor out? Okay, let's factor out the 5x squared. If you factor out a 5x squared, you're left with x squared minus 2. Okay, now what cancels? The x squares, like that. You guys see that? Now I'm going to evaluate. I no longer have to write the word limit if you put numbers in there. 3 times 0 plus 20 over 5 times 0 minus 2. You get 20 over negative 10. 5 times negative 2 is negative 10, which I get negative 2. And I make mistakes often, so let me know if I made a mistake. Are we okay so far, guys? All right, let's go to the next one. Again, letter C. Can I do direct substitution? No. Hopefully you remember some of these from pre-cal from last year. We did it in the first 9 weeks when we messed around with some of these. All right, we're going to have to do a common denominator in the numerator. So I'm going to multiply the right-hand side here by 2 plus x over 2 plus x. That's the same thing as a 1. I'm going to multiply this left term here by 2 over 2. So here's what we have. Limit, as x approaches 0, of 2 over 2 parentheses 2 plus x. If you want to distribute it, you can, but I'm going to leave it like that for now. Plus 2 plus x over 2 parentheses 2 plus x, and all this is still over x. Are you guys still safe? How much space do I got? Oh, I got plenty of space. Okay. I am going to simplify that further. Limit, as x approaches 0, 2, and I'm going to distribute that negative like that, see? Minus 2 minus x over 2 parentheses 2 plus x, close it. And can I write the x right there like that? Can I do that? We had the same discussion last year in pre-cal. In case you're wondering, like Chavez, I don't know how you did that. It's like doing this, guys. A divided by b over c. That c is like saying c over 1. Keep, change, flip. A over b times 1 over c, and you get a over bc. So notice that the c is right next to it. So that means I can just go doot. So that x down there, I can just bring it up right there like that. Cool? Okay, here we go. What zeroes out in the numerator? The 2's. And then what cancels out from the numerator and denominator? That x right there. Now I still have a negative 1 in the top, so don't freak out about that negative 1 there, guys. So equals, let's do direct substitution. Negative 1 in the numerator over 2 plus 0 is 2. What is 2 times 2? There it is. What's up, Parker? I put a 0 for the x. 2 plus 0. You know what I mean? No, you're good, you're good. I can't read minds, guys, so please ask questions. Okay. Look at letter D. And maybe we don't have enough experience yet to answer letter D. Here is what you know. Limit of happy face approaches 0 of sine happy face over happy face. That equals 1. So I have a 2x in the top, and I have an x in the bottom. No, I'm gonna leave it like that. I need the bottom to also be the same as the top. And I know you were just saying, but that doesn't say 2x, that says x. Well, it's approaching 0, so this doesn't really matter. That can be awkward face. It doesn't have, as long as it's approaching 0. But these two here must match. What are they called? Arguments? These arguments, well, I guess you can make a case that the denominator is not called an argument, but sine of something, that's an argument. These arguments must match. So if this arguments must match, I have a 2x in the numerator, it's sine of 2x. What do I need in the bottom? So let me write it. limit as x approaches 0. I'm going to go ahead and write it like this, guys. Sine 2x over x. And I'm going to use a different color. I need what next to that x there? Yeah, I need a 2. Now, if I put a 2 in the bottom, that's magic. I need to balance it out. If I put a 2 in the bottom, I need to put a what in the top? A 2. So everything in blue is brand new. So now, let me circle in green. What is this that I'm circling in green? That is 1. So now you have 2 times 1. Do you guys see that? So the limit is 2. So limit as x approaches 0 of sine 2x over x equals 2. Don't worry, guys. We didn't go that far, so we'll catch you up pretty quick. Yes, ask.
Why? I guess we just missed it. Why'd you put the 2? Where'd you get the 2?
I need this inside. I need the bottom to match this. So the only way I can do that is I have to put a 2 in the bottom. Now that's magic. If I write the 2 in the bottom, I have to balance it. So I have to put a 2 in the top. Because if I put a 2 in the bottom, like I'm making it heavier in the bottom. So whatever I put in the bottom, I have to do in the top to balance it. Like in chemistry.
So why is the sine 2x over 2x?
Oh, because it's if you were to graph that, it'd be the same graph, but with a little compression. But as you approach 0, it would still be approaching the value of 1. You know what I mean?
So sine 2x over 2x is the same, just like
Pretty much, yeah. It's going to look the same as x approaches 0. It's going to have the same more or less.
okay. But what if it was like sine 5x?
Then you better have a 5x on the bottom.
Okay.
You know what I mean?
And then if it was like sine 5x over 5x?
That's 1.
Oh,
Only if x approaches what? 0. Only 0. All right. I think we're good. Now we got some harder ones here. Don't worry, guys. We're going to go slow. Can I do direct substitution for x cubed minus 125 over x minus 5? No, because you don't, you get a 0 in the denominator. So, the top, hopefully you recognize, this is 5 to the third power. Do you guys see that? 5 to the third power is 125. Yeah, arithmetic might be a little off because of the 1.5 year there. So, this is the difference of cubes. Do you remember the difference of cubes? Travis, I don't remember anything. No, I'm not. That sounded bad. I apologize. Travis, what's the difference of cubes? Let me write it. I said silently, Travis, I don't remember anything. But I wasn't making fun of you guys, I promise. A squared plus AB plus B squared. Sometimes I don't even remember what I did yesterday, guys. So that's the difference of cubes. Do you know the sum of cubes? A plus B, A squared minus AB plus B squared. The bottom one is the sum of cubes. The top one is the difference of cubes.
are these similar to difference of squares that we should just like memorize?
Well, if you know Pascal's triangle, you can do it that way, or just have them, like, just know them. Are we okay, guys? All right, check it out. Knowing that that's the difference of cubes, I'm going to expand the numerator. Limit as x approaches 5. If you haven't evaluated yet, you write the word limit. X minus 5, close, open. X squared plus 5x plus 25 over x minus 5. What's going to cancel? X minus 5's cancel out. Now can I do direct substitution? Yes. So now I have 5 squared plus 5 times 5 plus 25. Let's see, 25 plus 25 plus 25 is 75. Sorry. All right, Chavez. But what about letter F? I don't know what to do with that. As soon as you see a sign X, the only rule we know is what? That's all we know. Sin X over X. That's all we know right now. So, look at the numerator on that one. That's giving you a huge hint. Limit, as X approaches 0, of sin X over, what can I factor out in the denominator? An X, and you're going to have 2X minus 1. So here's how I'm going to separate it. And don't worry, I'm going to slow down. Limit, as X approaches 0, I'm going to write a giant parenthesis. I'm going to write sin X over X, that's the only one we know, times 1 over 2X minus 1. Have I changed anything? No, I haven't changed anything. Let's see. What is sin X over X as X approaches 0? 1. Can I do direct substitution on this rational? Yes, on that one I can. Now I can. 2 times 0 is 0. 0 minus 1? Negative 1. 1 divided by negative 1 is negative 1. So this limit is what? Negative 1. Limit as X approaches 0 of sin X over 2X squared minus X is nothing more than negative 1. Are we feeling okay?
Wait, for the sin X over X,
Uh-huh.
how do you get one again?
Oh, well, I got one from, the first time I got it from the table, from way over here. The first time I got it from the table here, and then the second time I got it from the graph, that we looked at the graph, and it was, you know what I mean? Are we still okay? All right. You guys ready for this one? Here's your pre-cal. You see 1 minus secant squared, and you're thinking, well, I don't know anything at the moment other than sin X over X. That's all we know, guys. We know this. Limit, X approaches 0, of sin X over X. That's all we know. Okay. Oh, actually, we know two. We know that one, and we know which one else. We know, yeah, and through the shortcut, we know this one, which is actually a derivation of the sin X. So I'm going to put that one in there because maybe that's the easier one, instead of getting it to look like sin X over X. We know that one. Because we know that one.
Mr. Chavez,
Yes, ma'am.
can you please post attendance for a second, please?
Yes, ma'am.
Thank you.
Because we know that one. Don't worry, I'm going to post attendance, just not right now. I can make 1 minus secant squared look like tan squared, if you remember. So let's do a very, very fast review. Very fast. We know that if you're sine squared and your boy or lady is cosine squared, that together you guys are 1. You guys remember that, right? All right, and the only way I can get a secant squared is if I divide everything by, do you remember which one? Cosine. And if I divide everything by cosine, look what you get. You get tan squared plus 1 equals secant squared. If I do this one to the left and this one to the right, I get 1 minus secant squared theta is equal to a negative tan squared. And I probably should have done all this a different color. Now I'm going to have to do it all in blue or something. Are we okay with that? All right, here we go. I'm gonna solve for this in blue. I'm gonna replace 1 minus secant squared of 4x with negative tan squared of 4x. So I'm gonna write the word limit as x approaches 0, negative tan squared of 4x over, and I'm gonna go ahead and expand it, guys. Law of exponents, 6x times 6x is 36x squared. Are we still okay? All right, now we got to do like chemistry stuff. So we're going to expand it, and we're going to be balancing it out. So here we go. Chemistry is one of my favorite subjects. You guys remember covalent bonding and ionic bonding? What type of bonding is it between hydrogen and an oxygen? Covalent, yeah. Guys, there's like, I'm not saying it's common knowledge because I don't think it is necessarily common knowledge, but there is a certain amount of knowledge that you should definitely know when you graduate high school. And stuff like that is stuff that we should know. Avogadro's number, speed of light, molar mass, atomic mass, valence electrons. Okay. All right, sorry guys. Here we go. I'm going to expand it like this. I'm going to put the negative there. I'm going to go tan 4x, and I see that I have x squared there, so I'm going to put an x down there, times tan 4x. I'm going to put an x down there. I'm just expanding it. 1 over 36. I just expanded it. Everything in blue is the original. If I multiply all that, do I still get the negative tan squared 4x over 36x squared? Yes. I'm going to change my color because now we're going to balance out my equation like in chemistry. Yeah, 3 oxygens, blah, blah, blah. What do I need in the bottom for the tan 4x over blah x to be a 1? It follows the same rules as the sine x over x. I need a 4. If I put a 4 in the bottom, I got to balance it by putting 1 in the top. 4. So there it is. It's balanced. Do you guys see what I did? Because tan of happy face over happy face is equal to 1. I need these to match. Yes.
Oh, and you're just putting the floor wherever.
Yes. Well, and I have another one though. So look at the next one in the middle. Tan 4x over x. What does that one need? Another 4. So if I add another 4, I got to put another. I'm balancing, guys. I need my arguments to be the same. Cool or not cool? All right. So now I think I have it ready. I think we're ready to go. So let's see. This right here, I know I see a negative in the front, but that right there that I just circled, all that is 1. And yeah, with the negative is negative 1. And then this one that I'm circling again, that's also another 1. So I have negative 1 times 1. And then this right here, let's see what that is. 4 times 4 is 16. 16 over 36, which reduces. What does that reduce to? Yeah. So I'm going to write limit as x approaches 0. And I'd like to write the original expression again. 1 minus secant squared of 4x over 6x squared, the whole thing, equals a negative 4/9. And that's about as hard as it gets. How do we feel?
I would think of all of that.
Well, we need more experience, obviously. All right. So at the moment, you are good enough to do UH quiz. Don't worry, it doesn't have the hard trig ones. UH quiz 1, limits 1. And this is the one that I want to see an attempt today. Just an attempt. And the due date, I think I put the due date on Canvas as for this Friday. If you're ambitious, I don't remember the name of the quiz. I want to say it's quiz 5. It's called trig limits. And guess what trig limits has? A whole bunch of trig limits like this. Don't worry, I still do not have an attempt date on this. This is just if you're ambitious. If you're ambitious and you want to, make an attempt, this one will be next eventually. So for now, you now have the knowledge to tackle that one because I think we now have enough experience for it. We will do a whole bunch of algebra tomorrow. So tomorrow in lab, we're going to